Why software engineering? We will talk about what is software engineering, object of software engineering, software crisis. First of all, what is software engineering? Software engineering is defined as analyzation of user requirement, then designing, building, and testing software application which will satisfy those requirements. Definition and terminology controversies. The Bureau of Labor Statistics IEEE system defines software engineering as the systematic application of scientific and technological knowledge, method, and experience to the design, implementation, testing, and documentation of software. In similar, an engineering discipline that is considered with all aspects of software production. Fred's Bureau, the establishment and use of sound engineering principle in order to economically obtain software that is reliable and works efficiently on real machines. Merriam-Webster, a branch of computer science that deal with the design, implementation, and maintenance of complex computer programs. Software engineering tasks and responsibilities. A software engineer is in charge of design, development, and shipping software. They take the ownership of the software from prototyping and design functional code to coding and testing until it's handed over to the client. Now we will talk about tasks. Improving system quality by identifying issue and common pattern and developing standard operating procedure. Enhancing applications by identifying opportunities for improvement, making recommendation and designing and implementing system, maintaining and improving existing code bases and peer review code change, leading with college, implementing techno design, investigating and using new technologies where relevant, providing written knowledge transfer material. Most common responsibility for software engineers. Applying software engineer principle to analyze and problem solve and design a solution. Adopting agile methodology to develop software. Analyzing existing system to provide recommendation for improvement, creating technical satisfaction, designing and developing test cases, developing and executing project plan, ensuring proper documentation, maintaining system performance and performing predictive maintenance, performing system risk and reliability analysis. What is the difference between software engineering and programmer? Computer programming take a guide from software engineer and converted them into a written code and a structure that computer can follow. Computer programmers can create the fundamental style of a software system and turn it into reliability by writing code. Software engineering SES, also known as software development, are capable of creating developable software system. Software engineer analysis analyze. Software engineers analyze user needs, company requirements, and budget before design, development, and implementing software system to meeting that demand. They are also concerned with creative work, which is necessary when developing new system or ABBS. Why is software engineer necessary when we have programming? Why is it the difference between software engineering and programmers? The difference between software engineer and programmers. Software engineers analyze user needs, company requirements, and budget before design, development, and implementing a software system to meet the demand. Computer programmers take guidelines from software engineer and convert them into written code and structure that computer can follow. Computer programmer can create the fundamental style of a software system and turn it into reality by written code. The high demand for software engineers: 1. Handling large projects. 2. Control costs. 3. Effectiveness. 4. Productivity. 5. Reducing complexity.
Objects of software engineering. A program or set of programs containing instructions that offer desired functionality is referred to as software, and engineering is the process of creating and building anything that serves a certain function and solves issues in a cost-effective manner. There are 9 main objectives of software engineering: maintainability, correctness, reusability, testability, reliability, portability, adaptability, interoperability, and efficiency. Software crisis. There is no single solution to the crisis, but one possible solution to a software crisis is software engineering because it is a systematic, disciplined, and quantifiable approach. Some causes of software crisis: increasing demand, increasing complexity, same workforce, same methods, increasing challenges, or same tools. Continuing with the causes of software crisis, the cost of owning and maintaining software was as expensive as developing the software. At that time, projects were running overtime and software was very inefficient, as well as software was never delivered. The quality of the software was low quality, and software often did not meet user requirements. The average software project overshoots its schedule by half. Non-optimal resource utilization, difficult to alter, debug, and enhance. The software complexity is harder to change. For preventing software crisis, there are some guidelines. Reduction in software over budget. The quality of software must be high. Less time is needed for a software project. Experienced and skilled people working over the software project. Software must be delivered and must meet user requirements. What is the difference between software in academics and software in the industry? In academia, you learn in depth, while in industry, you learn in breadth. In industry, you don't have to work with a research machine for 180Z running CPM and a crappy basic interpreter. Academia is a study of how to make algorithm or programming paradigm efficient, while industry is focused on producing things that have to be sold. Academic programming is more about learning how to code something rather than understanding it, unlike in the industry. What is the difference between software in academics and software in the industry continuation? In a traditional undergraduate computer science program, you learn just programming, but the real world wants real software engineers to know how to gather and analyze requirements, work collaboratively on a team, estimate and plan work, create test plans, design architecture, communicate effectively with stakeholders, and negotiate schedule, budget, quality, and features without disappointing stakeholders. Regarding robustness in academia, the focus is on algorithms and function, and little regard is placed on the usability and stability of the software. Programming in university is unlike programming in the real world. CS will prepare you for real world software development. In academia, software is built with short term goals in mind, usually to complete a homework assignment. Once the assignment is completed, the code is thrown away. However, in a professional setting, most software is written with long term use in mind. Software is intended to be used for at least a few years and needs to be built to be easily maintained. This concludes our presentation. Thanks for watching and thanks for listening.